Today, I will give a lecture on captcha recognition based on the current neural network of long short-term memory. Captcha recognition, which belongs to OCR, is an Asian research field. This is a process of converting the handwriting information of a picture into a text. In recent years, with the development of large data, the majority of data scientists and network engineers in the study of captcha fields start to use some pattern recognition techniques of OCR. So in this article, when we mention OCR, it mainly focuses on captcha recognition, that part. So in OCR recognition, especially if we use deep learning techniques for this part, CNN and RNN may be preferable for this problem. So using this problem, it can help us be familiar with deep learning framework and handwriting recognition. That is very suitable. So as we know that traditional captcha identification algorithms is very violent, probably can be divided into 3 steps. The first is about deloising and binarization. The second is about the character segmentation. The third is about the each character recognition part. So respectively, the difficulty of recognizing captcha have corresponding difficulty parts in the 3 steps, such as for the first step, there is some problems on noise. We need to add a curve through the whole image, such as a grid line. And half of the image may divide into black character and white background, and the other half have characters and black background. The second is about a split part. Maybe some characters are sticked together. For example, for some samples, the captcha if the captcha have the number 7 and 4, they may be stick together, and it's very hard to split them. The third is identify. Characters may be distorted or rotated, so it's very hard to identify them one by one. So relatively speaking, the most difficult is the second step, split. So maybe some people think if we come up with a method that doesn't need to split the characters, maybe we can identify captcha more easily. So deep learning is good at doing end-to-end learning work. So it's appropriate for identification tasks, avoiding splitting text. I just use several deep learning and pattern classification techniques to better complicate the task. The first is RNN and CTC. CTC, which is called the collectionist control classification, is a better model for the pattern for the captcha recognition. As we know that traditional RNN models can focus more on the true sequence relations, but if we use it directly for the captcha recognition, as we know that the output sequence and the input feature sequence, especially for their size, is unequal. So use RNN models directly, it cannot solve this problem. Maybe it may result in a large data size for training. So CTC models can solve this problem. The main idea of it is that the system will add at first the system will add a blank character into the mark set. Then it then use the RNN to mark the left. So finally, it will remove the blank characters and predicted repeated characters to get much smaller sequences for output. The second is about the bidirection RNN. This algorithm is used for training parts. So the second is for the training part. We just use forward and backward algorithm, which is also called bidirection RN algorithms for this one. And the main idea of it is that for certain predicted sequences, we add some blank characters between the original characters, which generates the trellis, and then sum up all sequences that may be mapped to a given prediction. The third is RNN will LSTM. This is an improved RNN algorithm for solving the phenomenon of gradient varnish. A typical LSTM unit is shown as this part. In this part, the lab input part is used to obtain the input of the lab work at T time, and the output results of all LSTM cells at T-1 moment for its own layer. There are one or more new layers in an LSTM unit that describe the current state of the LSTM unit. And this figure shows the presence of three control gates, namely input gate, output gate, and forget gate. The outputs of the three gates are respectively connected to the one certain multiplication unit to control the input and output of the network, and the state of the cell unit respectively. After several operations, as long as the input gate is in the closed state, which also means the modification coefficient is 0, and the forget gate is open, which also means the modification coefficient is 1. Then the output of the network is continuously influenced by those operations. So this paper also will focus on RNN decoding methods. There are two popular methods. The first one is called the best path decoding algorithm. The second one is called the prefix tree search decoding algorithm. So in this paper, I want to use an algorithm based on neighborhood searching problems, and which is called the neighborhood decoding algorithm. For the feature extraction, I want to focus more on three features patterns. The first is on mixed features, which can be controlled by the sliding window of the image. The second is about the green value. The third is about the two-dimensional principal component analysis. For true DPCA extraction of the capture image, we first need to calculate the covariance matrix GT, and then we just on the training set B and B, we just use these equations to get the average value, average matrix, and make the estimating of the GI. And after estimating the covariance matrix, we need to calculate engine values and engine vectors. By transpose the matrix, we can make usable matrix sequence and ensure the scan of the image gradually forms the direction of the identified characters, which means that by using the two DPCA sequences, two DPCA features, we can make our system predict the sequences as the direction of the images input. The purpose of RNN output layer is to find the maximum sentence of characters corresponding to the probability of X, which is also called the decoding. So I just mentioned that there are two traditional methods on RNN decoding. The first one is about the best path decoding, which is to take the most probable path with a blank symbol. But this method doesn't necessarily correspond to optimal probability of the final result. The second is the prefix tree search decoding. That means that the system needs to obtain the total probability of mapping to the final result sequence, but the time complexity is exponential. In this paper, I just use the neighborhood decoding algorithm. This is a special decoding algorithm based on the neighborhood searching in table search. As table search, the optimal solution is obtained by the interval search in the neighborhood of the current solution. Similarly, in neighborhood decoding, the output of the best path decoding, this one, is obtained as the initial solution. And then we search the better solution in the neighborhood. Initial solution, assuming that the neighborhood for the initial solution is equal to this part, and also it matches this part. So the meaning of the about this formula is that when at time t and m equals 0, we select the output of the terminal pi max t and with the largest probability. Otherwise, we select the pi second t. Also, for the equation 2, this shows that the size of the label set is t, but not all of these passes need to be considered. So in order to further reduce the candidate path, the conception of the path confidence is introduced. So after obtaining the passes from the neighborhoods, the system first sorts the passes according to the confidence of the passes, and then selects the previous m passes for the next step. We use path array to represent a list storing multiple passes, and the initial value is empty. And pi cell t to represent the output at t. The basic steps of the label decoding is as follows. From the analysis, when m equals 1, the efficiency of the neighborhood decoding algorithm is equal to that of the best path decoding. Since this algorithm chooses solution from BPD algorithm as the initial solution, and only selects the sequences of characters with a larger posterior probability in its neighborhood, the recognition rate of the neighborhood decoding algorithms and therefore is no less than that of the best path decoding algorithm. And what's more, the time complexity of this algorithm is much less than the prefix search decoding algorithms because the latter one is exponential time complexity. For the experiment analysis, it's preferable to test a recursion test system with a common dataset. But as for me, it's very difficult to get a cohesive dataset And the capture dataset is very privacy for research. So I just use capture Python key to generate the capture images automatically. And these images shows the samples for the experiment. Also, for the environment of the experiment, I just use a platform of macOS 12 with 16 gigabytes memory, CPU, and TensorFlow 0.112 versions. Also, this images show the experimental results of the three decoding algorithm by using three kind of features. The first master 1 corresponding to the best passing algorithm, master 2 corresponding to the prefix tree search algorithm, and the master 3 correspond to the master 3 is the neighborhood algorithm decoding algorithm. From these images, you can see that mixed feature and the green value feature and the 2D PCA feature all obtain certain recognition rates, and the capture design requirement cannot exceed 5%. Therefore, the above characteristics have reached the requirement of recognizing capture in this experiment, which shows that the use of LSTM type RNN for cohesion and capture identification is a more preferable method. The recognition rate based on the green value feature is significantly higher than the based on the hybrid feature, and that based on the 2D PCA feature, which indicates that the green value feature is a good choice for RNN trading, and also indicates that RNN has the ability to extract features automatically. For conclusion, first, this paper proposes a method of capture recognition based on RNN with LSTM and CTC. It has a good recognition rate and can recognize character sequence with high adhesion. The third is that the algorithm focuses on studying the future extraction of capture, and it proves that a green value is an effective feature for capture RNN training. Also, this algorithm makes it real that we do not need to cut the character into single one for capture recognition. By using a neighborhood algorithm, RNN and training method can achieve higher recognition rates and lower the time complexity than other decoding algorithms.